Good morning. Um, Before we start a new section, I'm just going to have a quick answer for one of the question from the from other students. So hopefully this will giving you a little bit information on the composition. Okay, so I'm going to have a quick review on the composition in here. Let's see, let me share the screen in here. All right. Okay, so the question here is this one right here. Okay, hopefully you can see this one. This is a composition some people asked yesterday, and it's probably on a review test as well. This is trying to find a composition of f composite g, given the function f is 7 over 1 minus 2x, and then g of x is 1 over x. Okay, so apparently these both are the fraction. I know like people usually do not like a fraction, right? But we can handle this. In order for the f to composite g, according to the definition here, okay, f will be the outer, okay, so this is called the outer function. All right, let's see, we're gonna mark a little bit right here. So this f here, okay, let's mark this one right here. All right, so this f here is called a outer function. Okay, and then g of x here is called the inner. Okay, inner function in here. All right, so we have an outer inner, and that is this composition. So when you have this tiny circle here, all right, this is called a composition. Okay, this is a new operator. It's a kind of new operator in here. Okay, so what's the operator? Operator, just like addition, subtraction, multiplication, division, right? These are all operator. And this is a new one. So this is a new operator, which is only applied to the function, okay? So if we have a first one right here, f is called the outer, g of x is called the inner. So we're gonna call the, work inside out, right? So we're gonna plug a g of x in first. So g of x is 1 over x. So look at it, my g of x is 1 over x in here, 1 over x. So I plug this one right here by 1 over x, okay? So we plug this is 1, this is 1 over x in here. All right, so that is for g of x is 1 over x, g of x. So g of x is gone. Okay, so I have a function of f. All right, so what's the function of f? Remember this function of f, f can be, this f of the function, I like to using a star right here, right? So this can be or a 7. Okay, this is 7 over 1 minus 2 times whatever. This x can be replaced by anything inside the parenthesis, can be replaced anything inside the parenthesis in here. So where's my star? Okay, so that's 7 over 1 minus 2 star. So the inside the parenthesis here is 1 over x. So I'm going to replace this is a star or my bigger x in here, right? So think this x is a variable, can be changed by anything, can be changed anything inside the parenthesis here. So I have inside the parenthesis is 1 over x. So I'm going to replace my star is 1 over x in here. Okay, so you can think now, you can think this time my star here, this time my star kind of like a substitution, right? My star here is 1 over x, kind of like that. Ooh, okay, undo right here. This, yeah, my star here is 1 over x. Okay. All right, so now we have to simplify this one. We don't want to have a fraction and then another fraction here. So we have to simplify this one. In order to simplify this one, so we multiply this one in, right? 2 times 1 over x is 2 over x. So the quick and easy one to simplify this one is multiply the denominator. So I multiply x over x. This is called multiply by 1, right? X over x is 1. All right, so that way we can get rid of denominator, but make sure you have to use the parentheses, multiply the in. So x times 1, you got x, right? X times 2 over x. And then these two cancel out, you got 2. And then 7 times x, you got 7x in here. So that is the output for this one right here. Okay, that is the output for this one. In order to find the domain, we have to consider 2 areas for the domain. Okay, so what are those 2 areas for the domain? One area is, you know, the input. Okay, the input for here, the input. This is the outer function and inner function. The input for this domain. Think about it. This is kind of, I usually think of the function like a machine, right? So a function like a machine right here. You cannot throw rock and junk to the machine because you're gonna break it down. All right. So same thing as this one right here. Since I input g to the f, my input here for the f is 1 over x. This have to make sense. Okay. So we have to make sure this comply the 2 rules we have earlier. And this doesn't have a square root. This does have x in the denominator. So denominator cannot be 0. So we have this one right here. X cannot be 0, right? So that's the input. And we also, the output has to be meaningful. So the output also have x in the denominator. Again, the entire denominator cannot be 0. So we have this one right here, x minus 2 cannot be 0. So if you solve this one right here, so I have x cannot be equal to 2. So now we're going to have to combine these 2 points together. So we have x for this composition. X cannot be equal to 0. X cannot be equal to 2. Okay, because the input and output both has to be a value that way. So if I exclude these 2 points right here, I have a 3 interval, right? 1, 2, 3 interval in here. So I have a negative infinity to 0 and then union 0 to 2. And then from 2 to infinity. These all have to be parentheses because we don't want to include 0 and 2 in here. Okay, so that is the first part, F composite G. Any questions? All right, if you understand this question, the other one will be pretty similar, right? So how about if I write out G in the front, F in the second? Now that will be G composite F, right? And then G will be the outer. The first one is always the outer. Look at it, G is the first one. So that's G of F of X. So we have 2 layers of the function in here. I'm gonna plug the F of X in. So F of X is 7 over 1 minus 2X. So again, we're going to look at the input domain here. The input domain denominator cannot be 0. So minus 2x cannot be 0. You solve for x. X cannot be 1 or 2 in here, right? And then we're going to solve this one right here. So where's g? G is 1. G is 1 over x. Okay? So I can think g is kind of like a star in here, like a G. G is G of a star, right? So G of the star is 1 over a star. Instead of thinking this x, my x here can be replaced by anything, right? So now I have this star. This whole thing can be considered. This whole thing. Oh, hold on. Put and drop this one. Maybe where? Okay, so this whole thing is a star in here. Okay, so my star here, I can think of my star here. What is my star here? My star here is 7 over 1 minus 2x. Okay, so now I have a 1 over the star, 1 over the star. My star here is 7 over 1 minus 2x in here. Okay, and again, we have to simplify this one. So 1 divide this whole thing, divide this number is equal to multiply the reciprocal. So when we flip over, that's 1 minus 2x over 7. Okay, so what is my output domain? My output domain, I do not have an x in the denominator. So basically, this output domain can be anything, any real number, okay? But I still have to limit it by the input domain here. So this whole thing, this whole composition domain will be just limited by this one right here. We can just cannot be equal to 1/2, right? Cannot be equal to 2 because my output domain can be anything, any real number. So that will be just only 1 point in here. Okay. All right. So this one probably the most complicated composition, which you have two of them, both are fraction, right? And then you have to consider the input and the output for the domain, for the composition. Okay. So when we talk about domain composition, that is the whole composition, not just the F, not just the G, okay, but the composition domain. So this composition domain is different when you put this one in the front or put this one in the front in here. Okay, any questions about this one? All right, if not, we're gonna go ahead and do the number, I think, did I answer your question for the composition? Okay, so we're gonna go ahead and do the section 3.2. Okay, we did a 3.1 yesterday. If you want to, if you haven't reviewed it, you can go ahead. We're gonna a little bit ahead of the time because we don't have a office hour on the weekend. Okay, so that's why I'm kind of a little bit ahead of your schedule that way. All right, so we're gonna go ahead and do the 3.2 in here, which is called a quadratic equation. Okay, and we have to be able to find the zeros. Okay, so what does zero mean in here? Finding zeros of the quadratic equation. Okay, finding zeros of the quadratic equation and solve for the quadratic equation by using multiple methods. Okay, one is we want to have a called a square root method. Completing the square, we're gonna get rid of this one right here. We don't ask you to use completing the square method anymore. You can use the quadratic equation formula, and I will talk to you later on. Okay. If you go through the video from the textbook, you might also have completing the square, and that is nice now. But I'm going to show you using the quadratic equation formula. We usually let this one when you go to the pre-cal, okay, and then then this one. In the summer, very short, so we're gonna skip this one right here, avoid the confusion, okay? All right, so I think this quadratic equation formula, this is called a standard format, the standard format. So what's the standard format in here? You write down in a descending order, right? Ax squared plus bx plus c equal to 0. Make sure your right-hand side is 0. So that is the standard format. So if you want to use the quadratic equation formula, you must write down in this format, okay? And A, B, C are all real number in here, okay? So if I want to do the graphing, so how do I graph the quadratic equation? I cannot set the right-hand side. I cannot make this equal to 0 and put it in the calculator to graph, right? So I will have to write down y equal to, okay? So f of x equal to is y equal to ax squared plus bx plus c. If a equal to 0, so what is a equal to 0? Well, if a equal to 0, now this will be bx plus c. And this will be a linear, right? So my highest power is 1. This will become a linear. Okay, become a linear equation, a straight line. All right, it's not a quadratic anymore. So, but even a b equal to 0, if you have a y equal to, if you have a b equal to 0, c equal to 0, that's okay. So if I have a y equal to x squared, right, this is still a quadratic, okay, because I have a highest power is 2. So this is a quadratic. That means my a is not 0. My a here will be equal to 1, right? We don't write down 1 for a lot of things in here. So this is still a quadratic, okay? All right, so if you say you want to find a 0, that means you want to find the x value making y equal to 0, okay? So that's what called finding the 0 means. So what is the x value where y be 0? With y be 0. So what does y equal to 0 mean in here? if I do a little bit graphing in here, right? So I have an x and y. If I have this one right here, so that means I'm trying to find this point. Look at it. This is y equal to 0. This is y equal to 0 in here, right? So this is called the x-intercept. When y equal to 0, remember, if you learn from the chapter 1, when y equal to 0, that's finding the x-intercept in here. Okay, so that is this one right here. How about if I have a graph with something like that? If I graph with something like that, I don't have an x-intercept, what happened? Now, if you have a graph of this one right here, you make y equal to 0, right? And this can have an imaginary number, okay? This is called imaginary number of 0 for the quadratic because the graph doesn't pass the x-axis. And that means this one, you're gonna have an imaginary number, you're gonna have an I solution, okay? We talk the I solution on the fourth section in here. Okay, so you cannot have an imaginary solution for this quadratic. All right, so we're going to talk what I mean right here. So this is giving you a little bit overview. All right. For the quadratic equation here is, if you have a two number multiply equal to 0, what happened? One of them must be 0. That's the only thing in here. Okay, if you have a 0 times 2, it's going to be 0, right? So one of the number must be 0. Okay, if you have a 2 times 10, none of them is 0. This will be 20. This is not equal to 0. This won't be equal to 0, right? So, or if you have a 2 times 0, now this will be 0, right? So this is called a product. The multiply is the product. In order for the product to be 0, one of them must be 0. Either A or B must be 0. Okay, if both of them are 0, now that's good. That's even better. But at least one of them must be 0. And if we do not know which one will be 0, we're gonna say both of them to be 0. Okay, so if both of them have an x, now both of them will be 0. All right. So that is this one right here called the principle of the 0 product. Okay. All right. I'm giving you one example for this one before we move on from there. Okay. So for example, if I have x times x minus 2 equal to 0. Okay. So what happened in here? Well, if I have an x times x minus 2 equal to 0, so now my force this product right here, right? So this is multiply a product in here. So my first factor has to be 0, or x minus 2 has to be 0, right? So if I solve for this one, x will be equal to 2. Okay, so what is my solution for this one? So my solution for this one will be x equal to 0 or x equal to 2. Okay, so that is called the 0 product in here. Okay, if you have two factors multiply equal to 0, either one of them must be 0 in here. Okay. The other one right here is called the principle of the square root, right? So if I have x squared equal to k, for example, if I have x squared equal to 4, how do I solve for x? Well, I don't have to go to using the quadratic equation formula. I can solve this one right away. I will just have to take the square root on both sides, right? And when you take the square root, remember you have to have a plus and minus. So I can have either equal to positive square root or you can either negative square root. So this one I can have either a square root of 4, which is 2, or x can be equal to negative square root of 4. Okay, negative square root of 4, which is equal to negative 2. Okay, so how do I know both answers are correct? Well, if I plug that in, look at it. If I have a 2 square, I got 4, right? So when x equal to 2. How about if I have a negative 2 square? Well, if I have a negative 2 square, x is also, this x square is also equal to 4. So that means the x can be either 2 or negative 2. So that's why when you take the square root, you always have to have a plus and minus sign in here. Okay? All right, any questions? All right, so let's go to look at some of the equation in here. Now this time you will look at the factoring, right? I put a little bit extra points for the factoring at the beginning, which is very, very important, learn how to factor, right? So look at this one right here. In order to, we always have to right-hand side must be 0. So if you have a 2x squared minus x equal to 3, you cannot factor this one right here. So we're gonna have to minus 3 on both sides, minus 3, minus 3 on both sides, and then this is gonna be canceled out, right? This is gonna be canceled out on the right-hand side. So I have a 2x squared minus x minus 3 equal to 0. Okay, so that is this one right here. So we have this right-hand side equal to 0. Now, how do you factor this one? That would be a good question in here, right? So in order to factor this one right here, we have two ways to factor this one. Okay, one way is called FOIL factoring. Okay, if you kind of review this one before the class, I'm giving you some of the free video right there. Okay, so what is a FOIL in here? FOIL is the first term, outer, inner, and the last term. Okay, so how do you factor the first term, 2x squared? Well, my first term, 2x squared, the only thing I can factor is 2x and x. Okay, so that is how I factor my first term in here. So I factor into, that's the only way to factor 2x squared, right? So 2x times the x, we got a 2x squared multiplied in has to be equal to the first term. Okay, so that's the first term in here. And then we're gonna have so we finish the first term, and then we're gonna factor the last term. Okay, so how do I factor the last term? Well, my last term here is -3, right? So the only thing I can factor -3, since this -3 is a negative number, so I'm gonna have one positive, one negative, okay? And you can either factor into 3 or -3, because 1 times -3, we will get a -3. Or the other way to factor this one is -1 and 3, okay? -1 and 3 multiply also equal to -3. So I do not know which one. So we have either this one or this one. Which one do you use? We don't know. But we will have to go to look at the outer and the inner. Okay, so let's call the FOIL. You factor into 4 items. Okay, so the sum of this one, the sum of the outer and the inner has to be equal to -x. Has to be equal to -x in here. So that means if I multiply these two together, I got a number, and then I multiply these two numbers together, and then these two add up together has to be what? Has to be equal to -x. That is the goal in here. That's called a FOIL factoring. Okay, my outer multiply plus my inner multiply has to be equal to -x. That is the goal in here. All right, and how do I do that? Well, think about it. This my outer here is already 2x. So if I put a 3 right here, so we got a positive and negative. Those 3 I can only factor into 1 and 3, right? So if I put a 3 right here, what happened? If I put a 3 right here, 2 times 3 gonna be 6. Gonna be 6x. And then if I put a 3 right here, you must put a 1 right here. And 6 minus 1, it won't be -x. So apparently I don't want a 3 in here. So the smart way here is I put a 3 right here. I put a 3 right here. And then I put a 1 right here. Okay, so look at it. You have a 2x times 1. So what is my 2x times 1 right here? Well, my 2x times 1 right here, we are giving you 2x. Okay, my 2x times 1, we're giving you 2x in here. My 3 times x here, we are giving you 3x. All right, so that's how I figure out the number here. So 3 times the x, I got a 3x. 2x times 1, I got a 2x. And these two add up together has to be -x. So which one has to be positive? Which one has to be negative? Apparently this one has to be negative here, right? So -3x plus 2x will equal to -x. So that means this number must be negative, and then this number must be positive in here. Look at that. So that means we're using this one. We're using this one. So negative 3 times 1, you got a negative 3. So that is this one. That's the last term in here, right? So we can either 1 or negative 3 or negative 1 and 3. So we must using this one. And this must be in this position. I cannot switch 3 in here and 1 in here, right? Because this is 2. So when you have a coefficient number is 2 here, you will have to be very careful, because if you put a 3 right here, it won't work. If you put a 3 right here, it won't work. So 1 must be here, 3 must be here. And then that's it. That's how you get this factoring. Look at that. So we have x plus 1, and then that's 2x minus 3 in here. So it doesn't matter you write down this one in the front or this one in the second. It doesn't matter, right? These two are the same. This method is called a for your method, okay? So for your method, you kind of have to try and error, a little bit try and error in here. So that's for your method in here, okay? All right, any question about this method? Okay, I'm going to show you another way to factor this one right here, to factor this one, okay? So that's a little bit multiple way in here. So another one right here is I'm going to just write down, I can write down this one right here. So I have a 2x and then 1x in here. I'm going to write down this one right here. Okay, and now using the cross multiply, okay? The cross multiply together will be equal to, same thing will be equal to negative x in here. So how do I get a negative x? Well, same thing, I'm gonna put a negative 3. So if I have a 3 right here, 1 right here, so it will be 2x times 3, and then there's 1x, so this doesn't work, right? So this one doesn't work. So I'm gonna put a 1 right here, I'm gonna put a 1 right here, and then put a 3 right here. Look at that, so 2x times 1, you got a 2x, right? And then 3 times x, so cross multiply, you got 3x. And I'm gonna have to have a negative x, so I'm gonna have to minus in here. So this will be negative. This will be negative. And then if you have this one, 2 times x positive, and then x times negative 3. So these two add up together is negative x. That is another FOIL in a different format. And then when you write down the cross multiply, you write down the horizontal way. You write down the horizontal way. So I'm gonna write down this one is 2x minus 3 times x plus 1 equal to 0. Look at it, you got exactly the same symbol in here. Okay, so that's for your method in another different way. You can kind of check this one right here, check the multiply very quick using this one. This is the same as the one I just do using the FOIL, okay, and then write down in a different format. So that's another one right here, okay, another method. And I'm gonna show you which is I think especially some of international students in the past, they like to using the called okay, grouping method. This is also the one in our textbook in here, not in the college algebra, but in the developmental math, right? So called a grouping. So what is grouping method? We're gonna put a grouping. Okay, this is the first time I'm talking the factoring, kind of review the factoring, okay, giving you all the method in here. So grouping method here is called AC method. Okay, so AC method. So what is the AC method in here? All right, AC method is I'm gonna find my A and C together. Okay, so what is my A in here? Let's write down the lowercase. Okay, all right, I'm gonna write down the lowercase in here. So let's see. All right, so we have a 2x squared minus x minus 3 equal to 0. Remember, if I write down the standard format, okay, so where's my A here? My A here will be 2, right? And my B will be negative 1. My C here will be negative 3. That is you compared with the standard method in here. A is 2, B is negative 1, C is 3. Okay, so what does the AC method mean? I'm going to multiply A and C together. So it will be 2 times negative 3, which is negative 6. Oh, negative 6 in here. So I'm gonna go to break down -6 into two numbers. Okay, so two numbers. So you can have a 2 times 3, right? And these two numbers add up together has to be equal to the middle term, which is -1 in here. So that means I'm gonna have to have a if I have a 2 in here, if I have a -1 in here, my add up together will be just 1. So this is not the right one right here, right? This won't be the right one. Okay, this won't be a right one. If I have a 2 and a -3, add up together, this will be -1. So this is a correct one, right? And when you factor this one right here, actually you can also factor 1 and -6 or -1 and 6. Okay, remember when you factor this one, don't forget the 1 and itself. So these two add up together will be -5. These two add up together will be 5. So none of these is equal to -1 except this one right here. So that means I'm going to break down the middle term into this one. Okay. So how do I break down the middle term into this one right here? So I will have a, okay, let's write down in here. I will have a 2x squared plus 2x minus 3x and then minus 3 equal to 0. Okay, so what happened in here, I break down this into 2 and -3. So I break down my negative x in here. Look at that. I break down my negative x in here into two terms. I have a 2x minus 3x. So 2x minus 3x is equal to -x. So that means this is the same as the previous one, right? And that is called the AC method. I break down into the middle term into two terms. Now I'm gonna go into group 2 and 2 together. Okay, so that's also called grouping method. AC method is also called grouping method. So I'm gonna group these two together in here. I have a 2x squared plus 2x. Okay, group these two together in here. And I'm going to put a negative outside. So this one will be minus 3x plus 3 equal to 0. Okay, so we put the negative one outside in here. So I have a, when we put a negative one, both will be positive, right? And then we're gonna factor called the GCF, the GCF. So what's the GCF? The greatest common factor. Okay, so we factor greatest common factor out for each one. So this one, we have a common factor here is 2x. And then we have x plus 1 left, right? When you take the 2x out. And then this one common factor, I have a 3, okay? And then if you pull 3 out, this will be x plus 1, okay? All right, now they have a common factor as x plus 1, okay? And what's that? We have a 2x minus 3 left equal to 0. All right, so we got the same factor in here. Look at that, we got exactly the same factor as this one, okay? So this one is called a grouping method, also called the AC method. You multiply A and C together, and then you got this one right here. Okay, and of course you make each parenthesis equal to 0, and then solve for x. Make each parenthesis equal to 0, and then solve for x in here. All right, so solving x should be pretty easy as long as you can do the factoring. Okay. So that is this one right here. And factoring is very, very important, right? Because you're gonna use for the pre-cal, for the even for the trigonometry, for the calculus. I also teach calculus, Cal 1, Cal 2, and so on. So you know, factoring. Sometimes some people when I don't know how they got to the calculus too, and they still, you know, kind of do not know how to factor, right? So that's pretty sad that way. So you want to learn the factoring from very, very beginning, okay? So I'm giving you all these factoring methods, 3 methods to factor the same one, okay? And that is very important that you learn how to factor, okay? So that is this one right here. So that's the factoring in here, okay? Any questions? All right, you can check the solution in here, but for the quadratic checking is optional because, you know, you can always check on your own in here. Now for the quadratic in here, x can be, you know, for this For this equation, there's no x in the denominator, no x in the square root. So the domain here is all real number for the quadratic, okay? So that's why checking is optional. As long as you find the answer right, as long as you factor right, your answer should be correct. Okay, so how do you check? Well, you plug x equal to whatever the number, the solution, right? This is x equal to -1 in, and then trying to see if left hand side equal to the right hand side. If they are equal, that means you got the right answer, okay? Same thing, if you check x equal to 3/2, you plug x, replace x by 3/2 in and do the calculation. So you got the same answer. So that means you find the correct answer, that one, okay? So this checking is optional. Okay, you can check it on your own in here. It's optional. All right, not really required in this one. Okay. All right. We're gonna introduce another method to solve this quadratic equation. It's called using the formula, right? And this is the formula in here. If you wonder how does this formula come from, okay, it's called using completing the square method, and then you can use this one in here, okay? So how does completing the square method work? If you want, you pull the x a out, right? So you pull the a out in here, and then this will be b over ax, okay? And we're gonna minus c on both sides, so we have a negative c over a in here, okay? So I'm sorry, not really. Let's do this one first. Okay, so just do the step by step. If you want to prove this formula, which you don't have to, all right, equal to negative c in here, okay? You minus c on both sides. Oh, this is x. Okay, and then you divide by both sides by a. We divide by both sides, divided by everyone by a, divided by everyone by a, right? So this will give you x squared plus b over a x equal to c over a, negative c over a in here. Okay, that's c over a in here. And then we're gonna go to completing the square. So that means how much we have to add in order for this to be a square in here. You're gonna add half of this one. Okay, add half of this one, which is 2a, and then square them. Okay, and these three will become a perfect square. And then same thing, if we have to add the same thing on both sides. You will add the same thing on both sides, so this can be equal in here. So what is this square? This square will be x plus b over 2a, perfect square. Okay, and then you go to calculate the right hand side in here. This will be b squared minus 4a squared, right? And then we have a little bit LCD in here. So in order to make this 4a squared, so this will be have to multiply. So I have a b squared in here. Okay, I'm gonna put this one in the front, b squared, and then this you have to times 4a and then times c for this one in order to be the same denominator in here. All right, and you take the square root on both sides. Okay, you take the square root in order to for this one solve this one. So you will take the square root. Okay, take the square root on both sides, and then we're gonna have a plus and minus the square root for this whole thing. All right, so that's b squared minus 4ac over 4a squared. All right, and then if you get rid of this square, okay, this can be taken out as 2a, right? And then you're gonna have a square root of b squared minus 4ac here, minus 4ac here, right? And then you solve for x here, you minus both sides by this one. You minus b over 2a on both sides, minus b over 2a on both sides. So this will be canceled out. So and then you write down this one right here. So you have this one. So that's why you have a negative b in here, negative b plus and minus. This is b squared minus 4ac. Okay. So that we just so you have a same denominator. This is 2a. Okay, you have a same denominator. So that's how you completing the square. So that's we just prove this formula. We just prove how do you get this formula in here. Okay, so this formula is called using completing the square method to solve this one right here. But in our case, I'm not going to ask you to prove this one or using completing the square method. I am going to, if you have this one and if you cannot factor, right? If you can factor, actually factor will be quick and easy. If you cannot factor, the second method in here is using this formula, okay? Using this formula. So using this formula, you have to calculate very carefully. So this negative b is from the formula, okay? So you have to be very careful when you do this one right here. All right, so let's see if I have this equation right here, right? How do I find the exact solution? So what does the exact solution mean? That means if you have 1/3, you keep the 1/3. If you have a square root of 2, you keep square root of 2. Don't estimate into decimal point. That's called the exact solution. Okay. All right. So in order to use the formula, I'm going to have to write down the standard format. So what is the standard format in here? Well, the standard format will be what? Ax squared plus bx plus c equal to 0. I have to, in order to using the formula, I have to write down this one. So I have to minus 7 on both sides. So my c here is -7. C here is -7. A is 3, B is 2, right? This is all plus. So when you have a positive, this will be, A will be positive. When this is negative, C will be negative. Okay? And then plug it into the formula. So negative B, B here is 2, so -2 plus minus B squared minus 4AC, C is -7, right? And then you do the calculation, so that's 4, negative, this will become positive, okay? So you have a 4 plus 84, which is 88 in a inside the square root. This one you have to simplify, okay? So what is 88? 88, you can think of is 4 times 22, okay? And what is the 22 here? Well, 22 here is 2 times 11, right? But neither 2 or 11 can be taken out, so I'm gonna just leave the 22 inside. But 4 can be taken out from the square root as 2. So that's why you have a 2 square root of 22, okay? You have to simplify. This is called simplify the square root, okay? You have this one right here. And if I break down 22, I have a 2 times 11, which is cannot take out anything. So if we cannot take out anything, we're gonna just multiply that back, keep the 22 in here, all right? So we have a 22 inside, and then square root of 4 will be 2. So you have a 2 outside here, right? And this one you also have to simplify because this has a 2, this also have a 2, so you have a common factor of the 2. So you can factor 2 out. And then 6 you can factor into 2 times 3, so 2 and 2 can be canceled out, all right? Okay, so that is how you get this one right here, okay? And when you type it into the calculator, you cannot type a plus minus that one. So you're gonna have to separate this one into 2 answers. So -1 plus square root of 22/3 and -1 minus square root of 22/3. This is called the exact answer. These two both called the exact answer in here. Okay, so when the book says exact answer, that's what it means in here. All right, but you do have to simplify the square root in this case. Okay, and if you ask, you also run to thousands. So this th at the end, right? Thousands in here. So when we have a tenth, that means 1 decimal point, 1 decimal point in here. When you have a hundredth, that means we have th at the end. So that means a hundredth, right? Hundredth, that means you're gonna run to 2 decimal point. And this is thousands, so that means you're gonna have a 3 decimal point in here. 3 decimal point, that's called thousands. Okay, so when we say run to the thousands, that means you keep 3 decimal point. And of course, you have to look at the fourth digit to see if this one digit is 5 or above, you run up. 4 or below, you run down, right? So this one you can use in the calculator and then run to, go to the calculator in here. All right. So if you this, I'm kind of hoping you know how to use the calculator to go ahead and just plug it, the whole thing in here, okay? When you plug it into the calculator, you might have to use the parentheses on the top because you have a two item. If you forgot a parenthesis, your answer gonna be wrong, okay? So using the parentheses for the numerator before you put it into the calculator. So parentheses for this one and then parentheses, you know, close parentheses and then divided by 3, and you should be able to get the right answer. Okay, make sure you use the parentheses. All right, any questions? Okay, now let's see how do you solve this one right here. Well, do I have to use one thing is, do I have to use the quadratic equation formula? Well, quadratic equation formula is using ax squared plus bx plus c equal to 0, right? And then we have this x is equal to negative b plus minus b squared minus 4ac over 2a, okay? But if you check this one right here, my b is 0. Look at that, I don't have a b term. I don't have a b term in here. So if I have a missing b term, this one using the square root property will be really easy. So what's the square root property? If you have x squared equal to k, right? And I can have a plus and minus the square root of k right away. Look at that, this will be quick and easy using this one. This one is don't have a bx in here. So same thing, I don't have a x term in here. So this one, using this one will be much easier than using the formula. Okay, of course you can go to using the b equal to 0 using the formula, but not necessary. This will be much easier to use this one. So how do I use this one right here? Now I'm gonna have to put a x squared equal to k. So I'm gonna add a 10 on both sides, right? Add a 10 on both sides in here. We're gonna plus 10 on both sides, okay? And then this will be canceled out. So this will be equal to 10, right? And then I'm gonna divide by both sides by 2. So 10 divided by 2, I got what? I got 5 in here. So look at that, I have x squared equal to 5. So how much is my x? Well, I just take the square root plus and minus square root of 5. Look at that. If I take the square root on both sides, and then using plus and minus, of course, and I take the square root on both sides, square root of x will be just x, and then this will be plus and minus square root of 5. Okay, so using square root of property, this one is quick and easy. You don't have to use the formula for that one. Okay. All right, how about this one right here? Well, this one right here is not in a standard form. So we are trying to write down in a standard form, right? So for the quadratic equation, we like the right-hand side equal to 0. So I'm going to have a 2x squared minus 3x minus 1 equal to 0 in here, okay? So this one right here. And if I go to trying to factor, I usually like to try the factor first, right? So if I try to see if I can factor this one, the answer will be probably not. I cannot factor this one right here. Look at that. If I have a 2x squared, I can factor 2x and x, right? And then 1, the only thing I can factor 1 is 1 and 1, right? So if I have this one multiply 2x times 1, I got 2x. Some people say, oh yeah, if I have a 2x and then I have an x here, I can get a 3x. Right? But in order to get a negative 3x, these 2 must be negative. So these 2 must be negative. So that's how I can get a negative 3x in here. But this one is negative 1 times negative 1 won't be negative 1, it will be positive 1. So that means this one I cannot factor. If this is positive 1, yes, I will be able to factor. Okay, so I will be able to factor into a 2x minus 1 and x minus 1, and bam, this one is done already, factoring. Look at it, if I change this one into plus 1, I can factor into this one because look at it, last term multiply negative 1 times negative 1, you got positive 1 in here, right? And then inner multiply, you got negative x, outer multiply, you got negative 2x, so everything is done. You can factor this one. That's quick and easy. But unfortunately, we have a negative 1 right here. So this doesn't work. So that means we cannot factor this one. Okay, this is not factorable. So that means we have to, if we don't using the completing the square, we're gonna using the formula. So what is the formula in here? Well, my formula, we have to write down A. So my A here is 2, my B here is -3, my C here is -1, right? And then we're gonna write down the formula in here. So that will be -B plus minus, okay? This will be B squared minus 4AC over 2A, all right? And that's probably in here. So negative B, this negative is from the formula, okay? And I like to use in the parenthesis in here. So I have a negative B. My B here is -3, right? And then plus minus this will be B squared. So B squared is -3 squared. Look at it, negative has to be squared. Minus 4AC, okay? All right, over 2A, over 2A. I like to use in the parentheses, so that way I will know very well. All right, so 2 times 2 is 4, negative is positive, so I have a 3 right here, okay? And then plus minus, how much is this one right here? Well, this -3 squared is 9, so it's positive 9. Okay, let me write this one down. Is positive 9. And how much is this one? This one is negative times negative in here. Look at it. I have a negative here, so that should be positive. So this is 4 times 2 is 8, so that will be A in here, A in here. Okay, so what do I get? I got 3 plus minus square root of 17 over 4. Okay, so 17, I cannot simplify. I cannot take it out from the square root. So that's the answer. So that's why we cannot factor this one right here, because we have a radical solution. We have a, this is called irrational, right? Irrational solution. So that's why we cannot factor, okay? And on the homework, in the electronic homework, you have to separate into 2 terms, okay? All right, and then this one, minus square root of 17 over 4. So you have to separate into 2 terms for this one. And this is called the exact answer, okay? It's called the exact answer in here. All right, so most of the time you will keep the exact answer, okay? Probably very few times you will ask you to run to the decimal point. If you run to the decimal point, now you can use the calculator to estimate this one. Otherwise, this is called the exact answer, okay? All right. So that is using the formula in here, okay? Using the formula. A little bit concept here is called, this is called a discriminant in here. So what is a discriminant? Remember, we have this under the square root, right? So under the square root here, this is called, giving you them called discriminant in here. If this one equal to 0, you have exactly one real solution, okay? Because when you have a plus and minus 0, it's the same. So that's only one solution. What kind of case in here? This is the case like the graph touching the x-axis. So you have one solution in here. So that is exactly this case, okay? And when this is greater than 0, you have 2 different real number solutions. So what kind of situation is this one? This is kind of something like that you have 2 real solutions. So that means the graph passing the x-axis twice. So that is this one right here. If this one is less than 0, what happened? Well, we talked the domain there earlier. You cannot have a square root as negative. But since we learned the imaginary number, so that means this one you're gonna have a complex solution. Okay, you're gonna have a complex solution or imaginary solution. So what does this one mean? This one, that means this is kind of don't have an x-intercept at all. Can be either this one or it can be this one facing down that one, but you don't have an x-intercept. Okay, so that is using the discriminant. You can discriminant in here. You can know how the graph will look like and how many solutions you have. Okay. All right. The last thing here is, some of them homework you can kind of see. Well, how about if I have a 4 power in here? Can I solve this kind of question? If you have a 4 power, the answer is yes. If you have a 4 power, we can call using a substitution. Okay. So what is the substitution in here? We let u equal to x squared. So change x squared into u. So if you let u equal to x squared, what happens? Well, now this will be u squared minus 5u plus 4 equal to 0. So you're gonna, this is a quadratic equation, okay? And then you're gonna go to solve for u. One thing is when you solve for u, you have to come back to solve for x, okay? So how do you solve for u here? Well, this one you can factor really easy, right? There's u, look at it, this one right here. I just need to factor the last term. My middle term is negative, so this positive, I'm gonna factor into two numbers, -1 and -4. Okay, -1 plus -4, you're gonna get a -5. -1 times 4, you're gonna get a +4. So that's how you factor in here. Okay, so I'm gonna solve for this one right here. My u will be 1. My u will be equal to 4, right? Make a factor equal to 0. But this is not a final answer. My final answer, I have to come back to solve for x. So I have x squared equal to 1, right? So u equal to 1. And solve for x here, solve for x here. So x will be plus minus 1 right here. And then I have another solution here, which is x squared should be equal to 4, right? And then if you solve for this one right here, x will be plus minus 2. Okay, so you have a four solution. You have a four solution in here for the x. Okay, so this is called kind of reduced quadratic. You can kind of substitute. We call using the substitution method. Substitute x squared by u, so you can change it into quadratic equation in here. Okay. All right, so that is all for this section. Okay, for the quadratic, this is 3.2. Okay, 3.2 in here. So we kind of a little bit ahead of the schedule because we don't have a class on the weekend, so we kind of a little bit ahead. Okay. All right. Any questions? Do we have any questions? All right, I'm gonna stop recording.